Okay, so a quick video on structural isomers. Here I've got C4H10, and to name that I'm going to number my longest carbon chain. I'm going to look at the bonding in it, and hopefully we can all recognize that as butane now. So to get a structural isomer of this, essentially with structural isomers, what you're doing is you're chopping off this CH3 group and you want to replace that with a hydrogen from somewhere else in the molecule. So I'm keeping my carbon 1, carbon 2 and carbon 3. I'm keeping those as they are, and carbon 4 I want to move to somewhere else in the molecule. The key thing that I need to point out here is that I cannot take carbon 4 from the right hand side of this molecule and place it onto carbon 1. You can never put a CH3 group on the first or last carbon in the chain, because remember, you can turn the corners when you're numbering, and that's just going to give me back butane again. I've just drawn it out in a slightly different way. So you can never put it on the first or last carbon. That's the main thing I've seen a couple of people do in the homework that I wanted to point out to you. What I need to do is I need to take that CH3 group from the end, and I need to replace it or swap it with a hydrogen from the middle carbon. So in butane there's only one middle carbon, that's carbon 2. So my two options are to put the CH3 group on here or to put it on here. I can swap it with either one of those hydrogens. I'm going to swap it with the bottom one there. So that's my CH3 group that I've put on the middle there. No matter what way I try to number this chain now, going straight across like I have done already, I could turn the corner here, or I could turn the corner from this side. No matter what way I do it, I'm always going to be left with 3 carbons in my longest chain. Now, the hydrogen that I've replaced is this one. That hydrogen hasn't disappeared. I removed this CH3 from this bond here between these two carbons, and so my hydrogen replaces that carbon. So I put a hydrogen over there. All the other hydrogens in the molecule, nothing has changed about them. All that has changed is I have swapped these two pieces. I have swapped the CH3 group that was carbon 4 with the hydrogen on carbon 2. Everything else about this molecule is the same. To check that you have got a structural isomer and not just rearranged the molecules to still give you butane, you need to name it. You'll always be asked to name it. Here I can see in my longest chain I've got 1, 2, 3 carbons, so it's going to be propane. And my side chain, my branch, is on carbon 2 and it's a methyl group. So this would be 2-methyl propane. You guys seem okay with naming them, so I'm not going to spend time on that. What seemed to be the issue for some people was drawing them out. So I hope this has helped. Alright guys, another example, you need to know the isomers of pentane as well. So pentane is here, 5 carbons in the longest chain. Again, it's not showing you the hydrogens here because I don't want to confuse the whole thing. What I'm doing is I'm taking this carbon, so my CH3 group from the end, and I'm going to put it somewhere else on the molecule. Again, just to show you in the 3D one, I have put that carbon on the last carbon in the chain. So I've moved it from here and I've put it onto this carbon here. And as you can see in the video, both of these molecules, when you convert them to the 3D structure, both of them are exactly the same. So they're not isomers of each other. And then what I'm going to do now is I'm going to draw out an actual isomer. So I'm going to take that CH3 group from the end and I'm going to place it on one of the middle carbons. I can place it on either of those two. I've chosen to put it on that one. And so now you can see that I've got 4 carbons in the longest chain and the 5th carbon is now in a branch. And so when I load it up here, you can see down at the bottom there, it's over on the left here, the isomer. For some reason it did it backwards. But you can see the structure of both of these when they were built up is exactly the same. That's the two of those. Whereas when I've put it on a middle carbon, you can see the structure is totally different. Hopefully that helps you visualize it. These are like the kits we were using in school. So putting it on the end, you can't put a CH3 group on the first or last carbon in the chain, because that just lengthens the carbon chain by 1 carbon, giving you back pentane again in this example. You need to put the CH3 group that you're moving onto one of the middle carbons.